example comes out of Implicit Differentiation, section 2.7. Chapter or so, which is find the derivative and then find slope of a tangent at a certain point. But the method of finding that derivative is a little bit different. If I rewrite this expression, 3x to the 6 plus x cubed y plus y to the 4 equals 21, I defy you to solve for y. You've got a y term that's multiplied by x cubed, and you've got a y to the 4th term. So solving for y is not really a reasonable approach for this question. So what we need to do is, again, take the derivative of all of it with respect to x. Now, what does that mean? This first term, if I take the derivative, is just 18x to the 5 plus. Now, x cubed times y requires the product rule. We say, well, x cubed times the derivative of y plus y times the derivative of x cubed. Then I have plus, what's the derivative of y to the 4th? 4y cubed times y prime. And all of that equals the derivative of a constant, which is 0. So we have here kind of an unusual situation where we've got two different y primes. We haven't run into that issue before. So keep those y primes on one side. So if I leave my x cubed y prime here and my 4y cubed y prime here, but I subtract these other terms, negative 18x to the 5 minus 3x squared y. The reason why it's worth isolating these is we can now factor out that y prime term and say, well, I've got x cubed plus 4y cubed, and it all equals this business over here on the right. I can now isolate the y prime by saying, well, it equals negative 18x to the 5th minus 3x squared y divided by x cubed plus 4y cubed. Now that can be, tidied up a little bit by doing a little bit of factoring. Take out negative 3x squared on top, and I'll be left with 6x to the 3 plus 1y. All of that divided by x cubed plus 4y cubed. Nothing really further that I can do with it, so that's a pretty good expression for what my derivative equals. And notice in the implicit differentiation questions, your derivative often has y terms in it, whereas when our original function was y equals something, our derivative didn't have any y terms in it. Now for question A, for question B, provided we've done that part correctly, our slope of our tangent is just going to mean put in x equals 1 and y equals 2, because we're doing it at the point 1 comma 2. So I've got negative 3 times 1 squared, 6 times 1 cubed, plus 1 times 2. All that divided by 1 cubed plus 4 times 3 cubed. And it just becomes dealing with the numbers. 6 plus 2 is 8 times negative 3 is negative 24 on top. And then I have 1 plus 4 times 27 is 108. So negative 24 over 109, and so not a particularly nice, tidy answer, but an answer nonetheless that does give you the slope of the tangent to whatever that curve actually looks like. Again, the key point here, or the key spot, is to make sure that when you differentiate a term that has a y in it, that you end up with this y prime, or if you prefer to use the dy by dx notation, you have dy by dx each one of these times where you have a y prime up here. So this y prime, this y prime. Without those, obviously, you can't get to the answer here. So we'll try one or two more of those, and you've got some practice in textbook page 107.